Here's some still shots, so there's a couple of video clips at the end too. This is of the clamshell bucket and the boom and boom extension. Those are lead counterweights. I cast those in scrap 2x4. I drilled the holes and poured the lead and then split it apart. Turned them on the lathe to get them to smooth up and look nice. The pulleys on the top are part of a crown gear off of a slot car part. You could make those out of brass or aluminum real easy. I didn't have that stuff at the time. There's the calming line pulley assembly. The bigger wheel goes to the bucket and the smaller wheel on the right side with the counterweight out of lead pulls on that. Those ratios of the size is important. This is one of my earlier buckets. There you can see the separate jaw or tooth on the dragline bucket. That's dragline bucket, not clamshell. But the clamshell was pretty much made the same way. I pounded the brass around a piece of, I think it was 1-inch diameter wooden dowel. And then you got to clamp everything together and solder the whole thing as one unit. Otherwise, you end up with the solder joints coming loose because of the heat. There's the calming line on the left side with the counterweight. There's the old clamshell bucket that came with the crane, and next to my drag bucket. There's a close-up shot of it. I've never even tried that on this, and I'd have to make a doohickey at the top of the boom. You'd have to lift that thing clear to the top of the boom. That's what unloads it or releases it. There's a measurement of the base of the boom, and that's the extension. It's about 1.5 inches wide. Sorry for the terrible iPad camera. I think it's roughly square there in the center. I made it to match up to the tip piece and the main piece, so you know it had to fit those two connections. There's the overall length of the extension. There's another shot of the extension, and I just made it long enough to look pleasing, and I made all that out of aluminum. Here's a little video that I took that shows the process I used to make it. You can see one of them there was already made. I just used this to clamp it down so I could drill the holes, and I drilled holes at the end points of all of the interior cutouts. And then you're going to see me use a chisel. It's just a standard old wood chisel. I had to sharpen them once in a while, but this is, I think, 2024 T3 aluminum. It's probably 32 thousandths thick, and with it clamped in the vise, and you make sure that the jaws on the back side are not up above the jaw on this side, otherwise you're beating against the vise. But worked pretty good. I don't know why I tried it, but it worked out real good. I wouldn't have been able to do it any better with, you know, it would have been just terrible with a Dremel. You could do that, but I hate cutting plunge cut through stuff like this with a Dremel. I always end up making a mess, and it takes forever, it seems like. This, I thought, worked really good. You just have to turn it around in the vise for all of the straight lines, and that's how I did that part of it. And when you get it all done, it's sort of wrinkly, so there I'm flattening it back out on the back side of the vise. I didn't realize I had this video. I don't know if I've ever posted this or not. I thought maybe I did. And a lot of this stuff, if you're looking for more detail, look on the RC Truck and Construction forum, and I've got a thread in there of building converting the Nylint crane. It's a motor truck crane, and I converted it to radio control. I'm pretty sure there's still a bunch of videos and pictures in that thread of this conversion. Not so sure about this particular part. I don't remember if I ever posted this as a separate video. I think I did, but anyway. So the pieces pop out when you get to the last section, and then I've just smoothed everything out on the insides with a file when I was all done. Flatten it out. And I made these, the outer perimeter of these parts, there's 4 of these, for my boom, and I bought a second crane this summer, and and the boom on it, I thought it was going to be exactly the same year. I think there were 4 or 5 different model years that they made this crane, and I know they're all different, but the one I bought looked like the same cab and truck looked the same, but the boom is only 3-sided, not 4-sided. The first one I got that I converted is a 4-sided boom, and it's all spot welded together, and it's really nice. The new one I got, the second one, is 3-sided, and it's all flimsy and kind of beat up a little bit, but I'll probably end up putting a 4th side on that one if I ever get around to converting it or using it for anything else, because it's not nearly as robust as the first one I did. Finally, let's get this thing done here. If you can work that fast, you'll want to do it that way. You get done quicker. I didn't need to include the whole darn thing here, I guess. Anyway, I don't know if I finished telling you, the outside perimeter of these sections, these 4-side sections, fits inside of, I've also used angle, and it's also 32 thousandths aluminum angle, and that's the 4 corners of this extension. And so I drilled those to fit into the attach holes at the tip and the main boom. And then these kind of fit real tight or snug into the extension, so that I just glued them in there with some CA glue. You could epoxy it or whatever, and that seemed to work. I should probably do something to reinforce it, make sure they don't fall out. Here's a little video of the clamshell bucket that I made. It's mostly made out of brass. There are a few parts on here. These are lead. I drilled a hole in a scrap piece of 2x4 and melted some lead down in a tuna can, poured it in there, and then I turned them on my lathe just to smooth them up, make them look nice, and center drilled them. I don't even have the pins fastened in here yet. It works fine. You just need to watch, make sure they don't slide out. One of the things with operation of this clamshell, and I'm sure everybody that's built one knows that it really needs to be free. Nothing can bind. And where you end up with a lot of binding issues is in all of these points here, the pivot points here and here, and all those pivot points. If anything binds, what happens is it tries to stay stuck where it's at, and it won't want to close, and it tries to lift instead of close. And that's always the great big problem with a clamshell. And some of the old timers I've talked to have mentioned that the number of wraps that you have here, so the number of pulleys there, if I added another pulley, and I don't know what's common on full scale, but I think it's at least one more wrap. But the more wraps you have, the better the geometry is in it, and when it lifts the closer line, which is this line here, it's trying to close the jaws and not lift the entire assembly, because that's when it doesn't work effectively. If it lifts, then you're not going to fill the bucket. You won't get a full bucket full of material. And the material that you're trying to move is really important. It's related to how well it's going to work. A dense, heavy material, wet sand is nearly impossible. Well, dry sand is bad too. What happens with sand, and I don't know if you're going to be able to see it here very well, but on the teeth, and on this version, I made a couple of versions, I actually cut the teeth into this part, so it's all one piece. I had another one that I actually made the teeth and then I soldered that to the bottom. But if a piece of sand gets stuck in between the jaws a little bit, and it's dry sand, if it opens it that much as it's lifting, the sand just pours out of there. So by the time you'd get this thing to the truck or whatever you're loading or unloading, it has dropped half of the material out of there before you ever get where you need to be. These are just little joggle bends here on both sides to accommodate the pivot area. The heavier this thing is, the better. The first one I made, I did not put these weights up here, and I thought that helped the overall weight of it, so when you set it down that it tries to go in deep. You actually want it, let's see if I lift up here, you can see how it didn't really open up all the way, and that's part of the binding. So if I help it, you can see there's where it should open. So it's really tough to make this thing work effectively. It's probably binding up in here, and the geometry is going to make a difference. So my weights are probably at top dead center, so then they don't want to go on in. So there's all kinds of little design issues there. It looks so subtle, but yet I think all those things make a difference. So anyway, all the weight helps it set down as flat as possible so that when you start to close it, it'll grab as much material as possible without lifting. And then here's right away you can see another issue. If you don't operate it perfectly, these lines will get slack in here, and then they come off the pulleys, and just all kinds of little things. It's fun to use though. I love running it when I'm lifting, like the concrete block video. That's so easy because it grabs good. I don't quite understand what's going on there, but it'll lift really heavy stuff that I didn't expect, and it'll grab on it. It pinches on and lifts really good. And then you're not losing material if you're trying to move sand or dirt. It just doesn't work great for that. I think part of it is the scale. This thing probably isn't heavy enough for the scale of the material. If it were full scale, then that'd be a different story. I don't know if this is gonna be of a help. I had one of the viewers ask for a little bit more detail, so here it is. And then somebody asked about the boom. So that's at the front of the video, just some still shots. Fun little toy, had fun converting it, and still got some stuff I'd like to try to improve a little bit, but I'll get to that next summer when I get to start using it again. It's cold and rainy out now, probably snow here in a few weeks. See you later.